So today we are going to see about reciprocating pump and its different aspects. So there are different types of reciprocating pumps available. Here in this section we are going to discuss only about single acting reciprocating pump. So in the next section we will discuss about double acting reciprocating pump. So this is single acting reciprocating pump. So what is the difference between single acting and double acting? It is just the single acting pump will give one side delivery, and double acting will give two delivery pipes. So for each reciprocation of the piston, we have two different deliveries. So in case of single acting reciprocating pump, we have only one delivery pipe. So for each delivery pipe, we will have what is nothing but two different valves. One is action valve and another one is delivery valve. So one side of the piston diameter is capital D, and another side of the right hand side of the piston diameter will have connecting rod. So connecting rod diameter is kept as small d. So the water is lifted from the sump level to the pump level. This height is called as suction head. From the pump level towards the delivery point, the vertical distance is called delivery head. So if we sum both HS and HD, then we can have total head HS plus HD. So often these head kind of terms are measured in terms of height. So meter is the unit for the head, whether it is a total head or a suction head or delivery head, whatever it may be. We have to calculate it in terms of meter. So we know the piston diameter is capital D. And then the area available for the piston to push the fluid is pi by 4 capital D square. So D is the diameter of the piston. So often speed is measured in RPM. So RPM is nothing but revolutions per minute. So how many revolutions a pump take for a minute is called RPM. So this is measured in rotations per minute. So it is just a number per minute, number divided by minute. So for each revolution, the pump will supply certain amount of volume of fluid. So that volume we can calculate by multiplying area into length. So length of the stroke is twice that of the radius of the crank. So L will be often equal to 2 into R. So volume of the water for one revolution will be equal to area into length multiplied by area into length. So this is the volume, cylindrical volume formula, area multiplied by length. So area we can calculate from pi by 4 d square, and the length L is stroke length. So for one revolution, the volume that is filled by the fluid is AL, which is equal to pi by 4 d square into L. So in case of a reciprocating pump, we have n by 60 revolutions for every second. So for every second, it will give AL multiplied by n by 60 of volume for each and every second. So per second, it will give. So for one revolution, the AL is the volume. For n revolution, n into AL will be the volume. But n is measured in terms of RPM, rotations per minute. So we have to calculate rotations per second. For that, we have to divide 60, n divided by 60. So for one revolution, the cylindrical volume is AL. For n by 60 revolution, the volume available is AL into n divided by 60, which is nothing but volume of the water delivered for every second by the centrifugal, by the reciprocating pump, single acting reciprocating pump. So the final discharge equation will be Q, volumetric flow rate equation will be Q equal to discharge in one revolution into RPS, which is nothing but n by 60. N is RPM. So finally, the discharge, the volumetric flow rate Q will be equal to ALN divided by 60, where A is area, L is length, stroke length, N is RPM. So the unit for Q is meter cube per second. So in terms of volumetric flow rate, we already calculate the volumetric flow rate of the single acting reciprocating pump as ALN by 60. So what in principle we are interested in how much the weight is lifted for a single acting reciprocating pump. So in order to calculate the weight, we have to multiply the volume with respect to density and gravitational acceleration. So we already know from the Newton's equation, mass into acceleration will be force. So force into mass into acceleration will be force. Force multiplied by volume will give weight flow rate of the single acting reciprocating pump. So the equation we have to multiply, previous equation we have to multiply simply by rho g. So we will have weight flow rate, which is nothing but Newton per second, which is measured in Newton per second. So weight flow rate is termed as W equal to rho g ALN divided by 60.